again.
That's the first
You
set.
should have gotten how many 12s? You had 8 12s and 9 12s, right? 17 12s. 17 12s, how many times can you take 12 out of 17? One time, and how many 12s would you have left? 1 and 5 12s. Hmm?
That's what I heard the same thing.
1 and 5 12? 1 and 5 12s. And then, everybody understand that? Do we need to work that? Hmm? You get that? Okay. Anybody need that worked? Okay. Huh? Say it
To
again?
get the whole number when it's, when the numerator's bigger, you divide the, denominator by the, numerator, right?
Well, you do it any way you figure out to do it, but what you have to figure out is that, what you have to understand is that, what was the answer? 17 12ths?
Yeah,
What that has to say to you is that it takes 12 of them to make $1.
right,
You got 17 of them.
right.
I'm gonna take 12 of them out. How many times can I take 12 out of 17?
One time.
You can make $1.
Okay.
And then you're gonna still have some left, right?
Right,
You're gonna have 5 of them left, right?
right.
Those are still 5 12ths. That's what you have to understand. Now, what you are doing in math is dividing 12 into 17. Because I need to know how many 12s are in 17. That's what you have to understand. And that's, anytime you want to know how many of some number is in another number, that's a division problem. If I want to know how many 12s I can take out of 17, I know that anytime you see yourself taking the same number out over and over again, you are dividing by that number. Okay? And the number I'm dividing is the number that I want to know how many of them can I take out. So that's the number inside the box. If I have 17 of them and I know every time I take out 12, I can make another $1. You can do it any way you want to. I wouldn't make a division problem out of that. That's a waste of time. Because I know if I got 17, I can see I can only take 12 out one time. You see, if I understand what I'm doing, I can picture 17 things. I can draw 17 lines. Circle 12 one time, that's a hole. And I can see there are 5 left. You see what I mean? That's what I want you to get to, understanding what you're talking about and what's there. Not just memorizing processes of how to do it once you get here. You gotta understand, once you get there, you got 17 of them, it only takes 12. You have to understand it's the same thing as having, you may have maybe you have a bank that you just save dimes in. You got a whole bunch of dimes, you know they're not just gonna be dimes. You're gonna pour those things out and you're gonna pull out how many to make $1? 10. And you wanna know, every time I pull out 10 of them, I have another hole. So I'm dividing whatever I have by 10. You see what I mean? If I have nickels in that bank and pour them all out, how many of them do I have to pull out to make a hole? 20. You gotta pull out 20 nickels to make $1. You see what I'm saying? In this case, or in here, it was 17. It was 17, right? Or 12. What it was 12. So that tells you gotta pull out 12 every time to make a whole. You see what I'm saying? In dollars, we know what it is. But in fractions, it can be anything. Whatever that bottom number is, that tells you how many you have to pull out to make a whole. And you can think of it to make $1. That's, you know, people usually understand money a little better than anything else.
But
You can
it's
think
still,
it
it
takes.
still like relates to division though, in a way.
Well, it is division.
Yeah,
That's what I'm
that's what
saying.
he's asking, yeah.
And that's what I told him. Anytime you see yourself pulling out the same number over and over again, you missed that part. That's division. Anytime, because as the numbers get bigger, you're not gonna be able to visualize it. You have to know then that you are dividing by that.
Right.
You could have gotten something that said, I don't know, you could have had that. Now, I can't just see, you know what I mean? But that's what I want you to get to see, that what I need to know is, how many times can I pull 43 out of 137? Because every time I can pull 43 out, that's another whole. Now, division is a short way to do that, but I don't wanna say you have to divide, because I could do 137, subtract 43. That's one whole. Subtract 43 again. That's another hole. Subtract 43 again. That's another hole. And I'd have 8 left over. You see, I'm not gonna just tell you one way to do something. Because whatever you have, if you understand what's going on, whatever makes sense to you at that moment. You know, I may have done 43 into 137. This may have been easier, because then I still gotta think now, how many times is 43 going to 137? I don't know that just by heart. See what I mean? But I understand that I'm taking 43 away each time. This may have been a quicker way for me to start to get my answer. I'm all about you understanding what it's about, so that you can do it any kind of way that makes more sense to you. Understanding that division is the shortcut to subtraction, just like multiplication is the shortcut to addition.
So that would be, the 8 would be the whole, right?
The 8 goes on top of the denominator and then you reduce it.
Which 8?
On the, where you
No,
subtract.
okay. How many times I could take 43 out is the whole, because every time I took 43 out, I made a whole dollar. How many times did I take 43 out?
3.
So I have 3 whole dollars. What I have left are 8 of them. What are they? If I had 137 43rds, if I have 8 left, they're gonna be 8 what?
43rd.
8 43rds, that's what I had. That's what you have to understand. It's like saying I have 137 dimes.
Okay.
Every time I take dimes out, I make a dollar, but whatever's left on the floor is still dimes, because that's what they were. You see what I'm saying? If they were 43rds, I got 137 of them. You have to picture I got 137 of these things, and what they are 43rds. And it takes 43 of them, put them back together on the plate, and there's a whole cake. Get 43 more, put them back together on the cake, that's another whole cake, you see? Get 43 more of them, I can make another whole. But I don't have 43 more of them, I can't make another whole, all I have are 8 of them left. And those 8 are 43rds, because that's what they were. Follow what I'm saying? And so you have 3 whole things and 8 43rds, if this had been your answer.
Okay.
Okay? But this is what you're doing, and you're saying it goes in here 3 times. 3 times 3 is 9, 3 times that is 12. And I have 8 of them left. Okay? And then the third one there, 2/5 plus 5/6. What was the common denominator?
30.
30. 30 is the first multiple that they have in common. First one. So you have 12 30ths and you have 25 30ths. So you got what, 42 30ths? Is that what you guys had? Before you reduced it?
37.
Okay, I'm doing it in my head, so that's why I'm looking for y'all to tell me. I'm trying to picture. Okay, 47
Then it goes
30ths.
to 1 and 7 30.
So you'd have 1 and 30, 1 and 7 30ths left. Everybody got that one? See it there? That's good.
I
when
had
you
to
get
make
it,
sure
huh?
I did it again because I didn't want to be wrong.
Um,
Because like, I didn't know if like,
What did you know?
it had to be reduced and if I was.
Well, okay, and here's how you know if it has to be reduced. If there is a number that will go into both the top and bottom number evenly, then it has to be reduced. It has to be a number that will go into 7 and into 30 evenly, and there is no number, except 1. So then you know you're done. When only 1 will go into it, it can't be reduced into 30, okay? Okay. Let's look at some subtraction. Well, let's look at a couple of them. Let's look at number 5. Because in those ones at number 4, you didn't have any whole numbers, but it just makes sense. You can have, sometimes you have just parts. Sometimes you have some wholes and some parts, you know what I mean? You don't know what the number could be. It can be anything. So sometimes you don't just have pieces, you have some wholes and some pieces. So do number 5, just the first one there. The 9 and the 3rd plus 4 1/2. Same process, same 4 steps.
Three of them or just first?
Just the first one. And when I get to borrowing and subtraction before we leave today. And then tomorrow we're gonna do multiplying and dividing them. So that Thursday we're gonna start decimals. Yes.
Do all three?
Just number one, just the first one. And what is your answer? 1416, everybody get that?
Yeah.
Let's wait till everybody gets done, make sure. Make sure there are no questions. Anybody else got? All right. Any questions about that one? Anybody? Okay, now remember we said with subtraction is the same. If you look at the example right below